Hi everyone, greetings from Dortmund. My name is Katharina Eggensberger and I will teach the module on advanced hyperparameter optimization. As usual, we will start with the big picture talk. So we will talk in this module about how we can make Bayesian optimization ready for hyperparameter optimization. So let's have a recap on whether Bayesian optimization is an ideal method for hyperparameter optimization. So from previous lectures, we know that standard Bayesian optimization is built for sequential decision-making under uncertainty, in which evaluations are expensive and the objective function is unknown. This is exactly the setting that we have in hyperparameter optimization. We want to iteratively select a new configuration, and we don't know how our hyperparameters impact the performance value, and evaluations are expensive. Secondly, Bayesian optimization is theoretically grounded, well-established, and widely studied in multiple domains. This means we're building on a very robust method. Last but not least, it's based on minimal assumptions, standard smoothness assumptions, which makes it widely applicable also to hyperparameter optimization. So based on this, we could conclude, yes, of course, Bayesian optimization is suited for hyperparameter optimization. And in addition, it's more sample efficient than random search, more adaptive than grid search, and definitely more systematic than manual search. However, in practice, we might observe that the standard Bayesian optimization method is too inefficient for practical hyperparameter optimization tasks. Because if you consider modern pipelines where you pre-train or fine-tune or adapt large models, a single function evaluation might consume a lot of resources and takes a lot of time and is very costly. So we need to discuss ways how we can make Bayesian optimization more efficient. For that, we will in this lecture discuss assumptions that we can make to make our search more efficient. So let's see what we know about hyperparameter optimization of machine learning models. We have some observations. The first observation is typically we repeat our workflow. So we very often search the same space on different data sets. And if we assume that similar tasks might have similar objective functions, we can transfer knowledge and do meta-learning across tasks. Secondly, prior information is almost always available, either from previous experiments on different data sets, or manual exploration, or the domain or human experts. So we do not need to start from scratch when we start our optimization procedure. Thirdly, evaluating machine learning pipelines is often iterative. We can very easily get a low-cost approximate of our true costly function evaluation by only running it for a few epochs on a subsample dataset or another approximation. So hyperparameter optimization indeed has a lot of structure, and for this reason, we do not need to treat it as a generic black box optimization task, which might be unnecessarily general. So the summary from this introduction video is that, first of all, Bayesian optimization is suitable for hyperparameter optimization, and it can be improved by exploiting the structure of optimization problems. This is true for any domain. But specifically for hyperparameter optimization, we do observe task similarity, repeated workflows, prior information, and we can also get low-cost approximations in the form of intermediate results. So in the remaining videos, we will derive HPO-specific assumptions that increase the efficiency of Bayesian optimization for hyperparameter optimization tasks. See you in the next video.